Good morning everyone, welcome back to Question a Day. Today is July the 6th and we'll be answering July the 5th's question on coordinate geometry. So today is Build a Scarecrow Day today. So in preparation for the harvest or planting crops or wherever that celebration comes from, build a scarecrow. But before we do that, let's do this question. So this is a coordinate geometry question. We've got a line going through 2 points. And now for questions like this, if you're not quite sure where to start with them, it's always really good to have a bit of a sketch. It doesn't have to be really accurate, it just needs to have the important information on it. So we're going to start with this point A, which is at position 8 and minus 1. So that's going to come 8 units to the right and minus 1 down. So I can just kind of put that there. It doesn't matter specifically where I put it as long as it's on there. And I can draw B relative to it. So B is going to be at it's going to be at 4 and 7. So I can go backwards to, so if this is at 8, B is going to be at 4, but it's going to be much further above it. So B is going to be around here-ish. So we've got B and A. Again, I've not got any units on this diagram, nothing particularly accurate going on here. It's just so I can have it in my mind for when I'm answering these questions. First off, we've got to find the gradient. So we're going to be using the first formula. I think it's the first formula we actually learned in A-level. And it was that the gradient, m, is equal to the change in y, so y2 take y1, divided by the change in x, x2 take x1. Doesn't matter which way round we do this. So we could choose A to be our x2 and y2. We can choose B to be our x2 and y2. It doesn't matter which way we do this, all that matters is we keep it consistent. So we'll substitute these in. I'm going to choose A to be my y2. So we're going to get minus 1, which is its y value. We'll look at B's y value, minus 7. We're going to divide that by 8 minus 4. See, I've been really careful to make sure my x2 and y2 are from the same coordinate. So if we were to flip those round, we would get a different result. We'll just go through this computation. That's going to be minus 8 divided by 4, or minus 2. So that's our gradient of the line that passes through B and A. We call that line L. If you wanted to sketch this on as well, you could do that. I would recommend, if you are drawing on your diagram, do use a ruler. Again, it doesn't have to be the most accurate thing in the world, but you don't want to accidentally confuse yourself by putting kind of squiggly lines on, or not having 2 lines kind of intersecting at a roughly right point. So just make sure you're a bit more precise. You're as precise as you need to be, which again, it's one of those things that's a bit of instinct. It takes a bit of time to practice just how precise you have to be, but it's good to have as an ability. So the gradient of this is minus 2. We now want to find the midpoint. So midpoint is this bit that goes between them. And this was the second formula that we learned in A-level. This formula is that the midpoint is equal as a coordinate to the x-coordinate is x1 plus x2 divided by 2, and y1 plus y2, again divided by 2. In this case, the way around you do it doesn't strictly matter. Again, we can choose x1 as A or B, and x2 to be A or B as well. The only trick here is just being careful with your signs. Again, staying consistent, making sure you're using 1s for the same coordinate and 2s for the same coordinate. So now we'll do this computation. Now this is the same as, so our x-coordinates is going to be 8 plus 4 divided by 2, and our y-coordinate is going to be minus 1, right, don't know what I'm trying to write there, minus 1 plus 7 divided by 2. Because this is addition, we can kind of get away with swapping them around as we please. So it doesn't strictly matter. We could do 7 minus 1. That would give us the same answer. That gives us 12 divided by 2 and 6 divided by 2, which gives us our coordinate, get a paper down here, of 6 and 3 being our midpoint. So it's our difference between these two divided by 2. So our midpoint is going to be 6 and 3. Again, adding things to our diagram as we go along can help in that problem solving process. Finally, we wanted to find the distance between A and B. And this was our third formula that we learned in A-level. I think you may be seeing a pattern here. And distance was, we took this drawing and we used Pythagoras' theorem. And we said, well, this distance is a straight line, and actually it's the side length of a triangle. So if I imagine having my x and y axes somewhere on this diagram, it would make, we would get something like looking kind of like that with our grid lines. And so that's our vertical component, that's our horizontal component of this line between A and B, and they form a 90-degree angle, so that's a right angle. This is a right-angled triangle, which means we can use Pythagoras. And the way we work out these lengths, again, it's our difference in y and our difference in x. So this distance here is y2 take y1. This is x2 take x1. Now, you would think with the minus sign that you have to be careful again with the order you do them. Again, we'll keep doing it carefully, but in this case, it doesn't really matter as we're going to be squaring that distance anyway. So our formula that we had was we're going to take the square root of x2 take x1 squared plus y2 take y1 squared. We'll substitute in our coordinates. So we get our first coordinate, which is going to be 8 minus 4 squared. Our second coordinate, which is going to be minus 1 minus 7 squared. And if you want to play around with that, change the order here. So you could do minus 7 minus 1, and it would still give us our negative 8. It'd still be fine. Now this 8 minus 4 is going to be 4 squared plus minus 8 squared. And this hopefully tells you, well, this minus 8 is going to become positive as we're squaring it, which is going to give us a square root of 16 plus 64, or the square root of 80. And then that square root of 80, I'm very nearly out of paper. That square root of 80, if we simplified it down using our surds, we can see it's got a factor of 4 in it. And actually it's got a factor of 16 in it. So we can pull a 16 out of this. So root 16 times root 5, which, as we know, root 16 is going to be 4. So we get 4 root 5 as our distance between those points. Okay, so that's all our working. I'll just quickly give you a brief go over all of that. There you go. So a little bit of a longer one today, but hopefully the next one will be a little bit shorter than that. So I'll see you all tomorrow.